So in our previous video we picked up the idea that the length of a curve in rectangular form is given by the integral from a to b of the square root of 1 plus dy dx squared dx. And so this video is just going to focus on us sort of doing that computation, so actually finding the length of a curve for two different problems. The first we'll use in the graphing calculator, which is going to be the majority of the ways you do these problems, and the second will be we'll do the integral by hand, and a lot of these integrals just end up being in a place where it's very difficult to do them by hand. So a lot of these do end up being calculator problems, but I did want to give us some exposure to one that was non-calculator. So my first example, write an integral expression for the length of that function on the interval from 2 to 10, and then use your calculator to find this length. So for a lot of these problems, in fact I would argue for all of these problems, we can always set up an integral expression. It's just a question of whether or not you can compute the thing. So it should not be hard for you guys to do this one. So go ahead and write out that integral expression. Once you've got that, check back in and make sure you've got it right, and then use your calculator to compute it. So here we go. The first thing we need to do is we're going to need to figure out what the derivative is. This is a simple product rule, so we should have sine x plus x cosine x. Right. So now that I have that derivative, I can go and find the arc length. The arc length for this will be the integral from 2 to 10 of the square root of 1 plus sine x plus x cosine x squared dx. So in terms of the integral expression, there it is. Like this gives us the arc length. Please don't distribute this out. There's absolutely no need. We're going to take this whole thing and just throw it all into the calculator. And as one recommendation for you, in case you've sort of forgotten about it, one really easy way to plug this thing in so that you don't make mistakes with parentheses and things is to take this entire thing and store it in your y1. And that way when you actually get around to doing the integral, you'll just be putting in the integral of the square root of 1 plus y1 squared dx, and you're just a lot less likely to make mistakes with entering the thing in. So if you haven't done so already, throw that at the calculator, make sure you remember how to do that and you're not making mistakes on it. When I punched that into the calculator, I ended up with 34.38, 388. If you rounded, you could have also gotten 34.389. Either one of those would be acceptable on the AP exam. So those are my two different answers. If you got something wildly different than that, there's a chance that you're in degree mode, so make sure you're in radian mode. Because remember, anytime we're doing stuff in calculus, we want to be in radians. So for the next one, I want us to find the length of the function, the natural log of secant x, between x equals 0 and x equals pi over 4, and I will note this calculation should be done entirely by hand. This is a neat problem. It's nice how well this problem works out. So pause the video, try it on your own. If you're worried at some point, sort of watch through and see where you got stuck, and just check your work as you're going along. So surprise, surprise, our first step is to find the derivative. Even if you didn't recognize this thing up here, we could just do the derivative and say, oh, it's 1 over secant x, and then chain rule, so times secant x tangent x. Then we divide out the secant x. Turns out that the derivative of this function is just tangent x. Right? So there we go. Now that we have that, we can set this up to find our integral. Right? So for our arc length, we're going to do the integral from 0 to pi over 4 of the square root of 1 plus tangent squared x dx. And my sincere hope is that everybody recognizes that. And this isn't some crazy trigonometric integral that's coming back to haunt you from the previous chapter. This is just a basic Pythagorean identity. We remember that 1 plus tangent squared x is equal to secant squared x. So I'm going to end up with the square root of secant squared x dx, right? And once I have that, that means I just have the integral of secant x, right? So my arc length will be the integral from 0 to pi over 4 of secant x dx. And this is one of those memorized integrals. Presumably you remember that this is the natural log of secant x plus tangent x. And I just need to evaluate this between 0 and pi over 4. And that evaluation just means, we plug in the upper bound, we plug in the lower bound, and evaluate. So this will be the natural log of, I suppose I should write this out, the secant of pi over 4 plus the tangent of pi over 4 minus the natural log of the secant of 0 plus the tangent of 0. Sorry for the horrible handwriting there at the end. So now it's just a matter of evaluating this. The secant of pi over 4, that's 1 over the cosine of pi over 4. It's going to end up being the square root of 2. The tangent of pi over 4 is 1, minus the natural log. The secant of 0, that's 1 over the cosine of 0. So 1 over 1 is 1, plus the tangent of 0 is just 0. And we're nearly done with this thing, because we remember that the natural log of 1 is going to be 0. And so it turns out that my arc length for this section of the curve that we're looking at is nothing more than the natural log of the square root of 2 plus 1. That's my arc length. So that's how we compute arc length. Sometimes you'll be called on to just set up the integral expression. Sometimes you'll evaluate in a calculator. Sometimes you'll evaluate by hand. You'll just sort of need to do what's asked of you in the problem.